So the intermediate value theorem is a key property for continuous functions. The theorem states that if f of x is continuous on a closed interval a to b, and f of a does not equal f of b, then for every value m on the y-axis, between the interval there exists at least one value c in a of b such that f of c equals m. So if we have our graph here, this is a f of b, b f of b. These are 2 points. Some value m between the interval directly correlates with some value c. So here would be a value c, and that is how you would know that there would be at least one zero in the function. So if we looked at an example, if 2x cubed minus 6s plus 1 equals 0 on the interval 1 to 2, we'd have to find a solution or show that there's at least one zero in the function. So we'd plug in 1 cubed minus 6 times 1 plus 1. That would be 2 minus 6, which would be negative 4, plus 1, which would be negative 5. And then 2 times 2 cubed minus 6 times 2 plus 1 would equal 3, I believe. 2 cubed is 8 times 2 is 16 minus 12 would be 4 plus, or 2 plus 1 would be 3. So if we graphed that, that would be negative 5 down here and 3 up here. So that's how we would know that it would cross the interval and at least hit 1, 0 on the graph. One last problem would be x cubed equals the square root of x plus 4 on the interval 1 to 2. So we would bring this over here, x cubed minus the square root of x plus 4 equals 0, so that this would be a function now. So if we plugged in 1 and 2, it would be 1 cubed minus the square root of 5 equals some negative value, because we know that the square root of 5 is more than 1, so that would just be some negative value. And then if you plugged in 2 cubed minus the square root of 2 plus 4, which would be 6, we would know that it was some positive value, because we know that the square root of 6 is more than, the square root of 6 is less than 8. So it would just be some positive value. So that's how we would know on a graph from 1 to 2, some positive and some negative, that it would have to pass the interval and hit at least 1, 0.